Really welcome to this particular lecture. It's a very special lecture that I prepared for this occasion because invariably I am told that we don't get consultants. People don't approach us, or when we approach the industry, they don't respond positively, and so on and so forth. Again, maybe I was lucky, but I'm going to tell you that I never approached the industry, and still it happened. So how it happened, I'm going to share the story with you and see if you can create that kind of ecosphere to make things happen the way they should be. Okay, and particularly, as I was telling Dr. Santosh, today's lecture is primarily for faculty, because I'm basically addressing them, and they have a lot to learn and a lot to discuss with me maybe at the end of the lecture. And I would really like to see if this lecture today can break ice and you people can get on to that side. And then I'm also going to tell you what is expected of you and what is expected in the industry to make use of your expertise. Okay? I will go very slow, and please feel free to ask me something in between. Otherwise, anyway, at the end we'll have a discussion. Now, I'll just start with a few definitions so that you are really clear of what is what. An industry is set up to provide products and or services to the society so as to satisfy its perceived or anticipated need and make profit. So primarily they want to make profit, but this is the background. They have to satisfy a perceived need of the society, and in the process, of course, make profits. I'm sorry. Yeah, sorry. Now, a major constituent of the industry's human resources comes from the engineering institutions at the level of fresh undergraduates, who are then trained in-house to design, develop, fabricate, assemble, and market the products. So what I'm trying to say is that they depend on us, our institutions, to give them those youngsters who have got all the basic training, and then further they can be trained the way they want there, and then be useful. Okay, and in this particular statement you see lies all the secret of success. So please absorb this what I am saying. I repeat this part. A major constituent of industry's human resources comes from the engineering institutions at the level of fresh undergraduates, who are then trained in-house to design, develop, fabricate, assemble, and market the products. For an industry to increase their market share, they need to innovate and improve their products. This is where the role of industrial consultancy comes in. Again, I repeat, for an industry to increase their market share, they need to innovate and improve their products. This is where the role of industrial consultancy comes in. How? Let us see. If they don't do that, what will happen? Alternatively, they may have to buy patents, import technology, or set up the in-house R&D facilities, which may be beyond the means of most industries. Now, industrial consultancy is desirable for the industry as well as the faculty of the engineering institutions, as explained in the next couple of slides. Now, I'm going to explain to you exactly why they need us and why we need them. Because only when we understand this thing very well, then we know what to do to break the ice. Now, let us start with why engineering consultancy is desirable for the engineering faculty. Now, consultancy gives you field experience. This experience or exposure enables you to impart practical knowledge to your students and pose challenging problems. In fact, this is exactly, I'm talking my own experience, that this is how everything went in my life and how I filled up that need, responded to them in a particular way, and how they responded positively. Consultancy generates resources for your college as overheads, for yourself as your share of the consultancy fee, and for your laboratories by way of equipment and consumables. Many times when I took up those projects, I didn't have the facilities. And then, so I told them I need it. So they said, fine. Okay, we'll give you those machines, we'll get you this, we'll get you that. You set up, you train your students, and then, because I told them that all consultancy will be given to my students. Okay, so they gave me everything, and then of course they took the condition that at the end of the consultancy projects, these instruments or this equipment will be returned to us. Let me tell you something interesting. This is what I signed on, that I will be returning at the end of the project whatever they have given me. I did not have to return even once in my life. Notwithstanding the fact that I was committed that I will return, they never asked for it. Because basically, they wanted to make sure that it is used for them, and if they need, they will take it. But they never need it because I gave them all the knowledge that they needed, and they were happy with that. Not only that, because the students who are trained, who worked on that, they were welcomed by them as their employees. So what I'm trying to say is that it is a very nice situation, and I also learned the process. When I started, I didn't know it will work like this. In fact, my head of the department asked me once, since you are signing on this, are you sure you'll have to return this equipment at the end of the project? I said, anyway, they are giving to me, I'll use it and learn everything. My students will get trained on that. If they not fit that, let it do, and you might occupy space. But not a single, I did 125 projects in my life. Not a single instance was there where equipment had to be returned. It was never asked them. So because then they realized that it is better serving with me there rather than they're getting it in their factory. As I was saying, exposure to industrial problems and possible solutions increases employability of our students. Industrial problems gives you great professional satisfaction at the end of the day. Because for any engineer, the best feeling that you can have is, yes, whatever I knew I've been able to apply and it's working. That feeling is great. You really feel that you did something very useful, very interesting, and of course, also something will great. Often industrial exposure gives you problems, as well as ideas, research, development and innovation, which would eventually lead to innovative designs, research publications, and possibly a degree for your students. And in my case, all these things happen. But I'm saying here just one is that innovative designs that came out of it, research publications, not every time, once in a while, but then often it happened a degree for the student. In fact, many times they would then what should I say, send their employees who would register in our university under external registration program, and you would get MSc by research or PhD. Okay, and vice versa. our students would get trained there, and in the process, they will find that they are very useful. So as soon as they graduate out of this one, they are employed immediately. In fact, I'll tell you something very interesting. An exercise was done by our consultancy center, and they found that almost 30% of all R&D centers in noise vibration in the country, they are being occupied and managed by my students. So you can see that employability is one-to-one, because first we needed them, and then they found that there is somebody who has been trained in this subject. That's what they need. So they will, in fact, many times I had a peculiar situation. Only 3 students would be graduating that year under this one, and there will be 10 companies waiting to take them. So instead of they are holding interviews for selection, they're here. It will be almost my students interviewing the industries, whom they would, they will go. I'm just saying it's all question of supply and demand. Okay? Because 10 industries were interested and I had only 3 students to give. So it was the other way around. Now, sometimes you attract practicing engineers for a research degree to your university as external registrars. This may bring some sophisticated instruments, which as I told you later on, the remaining. Alright. Now, why is industrial consultancy desirable for the industry? So after all, it's not just our thing. It should be of interest to them on the other hand, it will work. Otherwise, it doesn't work. Let's see. Now, consulting an expert faculty member works out to be very economical in the long run. Because if they don't do what, look at the alternative. Because in this case, there will be no permanent addition to the technical manpower, and they get access to the latest knowledge and tried and tested technology. They may get their design team retrained in the process by arranging continuing education programs. They may acquire facilities for testing their products as per international standards, and this may help the industry to enter or capture international markets. And the consultant may help the industry to better understand and utilize any imported technology or patents. I'll just repeat one by one and explain it. See, when they engage an faculty member as consultant, they pay only for that month. They don't have to pay monthly salary, and no question because this man doesn't belong to their this one. So there is no burden on their system. He is not a permanent addition to the HRT. And because when he is working, these consultants, they get access to the latest knowledge and tried and tested technology. See, what happens is that often people talk of latest technology and all that, but to be able to use it effectively, you have to have certain knowledge. Unfortunately, I should be saying it, most of our industry people, they don't have that knowledge. Okay? So even if the technology becomes available to them, they are not able to absorb. Now, this faculty member whom they have engaged as consultant, now he does that. He understands all those terms, everything. He will be able to explain not only himself, but also to them. Okay? So this is very important, that this consultant is not responsible for that particular project or something. He becomes available to them as an expert in that field who can be consulted anytime they have any doubts. Another thing I'd like to tell you, if they don't have this, don't engage us as consultants, what they will have to do, they'll have to import that technology. And that's very costly. And even when they import the technology, it's very unfortunate thing. Like these outsiders, foreigners, they never give you the technology, knowledge. They just give you the technology as a black box. Just use it like this, that's it. And not only that, they'll say, our people will come in and then put it to use and we keep using. So you never got technology. You only got something to work on and paid very heavily for that. And at the end of the day, you're not wiser at all. And let me tell you something, very disturbing. See, I was approached by Kirloskar Copeland. You might have heard, they are into aromatic steel compressors. They are in Karad in Maharashtra. They approached me to set up test facilities for their, hermetically sealed compressor for this fridge, etc. So I said I can do it, but you are already Copeland. So already your Copeland in USA, they have all this technology. Why are you coming to me? You know what they said? Sir, they only have asked to go to you. You just see, it's, it's one side, I can look at the honor that, I was recommended by them. But look at, there is a problem behind that is a very negative thing. They didn't want to give their technology to Kirloskars. Okay? And they said, go and take from Munjal. So in a way, their technology remains with them. And not only that, when I read the smaller, what they call finer print, it was that what Munjal gives, that will also be ratified by them. And the so-called ratification, automatically they assume a higher level for themselves, and that whatever my calculations, everything, they have to be rectified. In the process, they will know everything I know, but we will never know what they wanted. They knew. So it was the technology transfer in the reverse way. I hope you are understanding the implications of this, because all of you should know this when you are dealing with industry, and how industry is sort of being almost cheated by the so-called collaborative companies abroad. So I, in fact, anyway, I took up that project. I gave them the design. It was fabricated, used, but I put my condition in that in the contract. I said no, my whatever I give you will never be shared with Copeland. Because I have a right to say, when they give you anything, they say it's for your eyes only. You cannot show it to anybody or share it to anybody. I have to put that condition. Our chairman of consultancy center, he in fact suggested that they deserve that kind of thing. So we put that note that these calculations or this design will stay strictly for Kirloskar Copeland company in Maharashtra and Karad, and not to be shared with the principals, Copeland Corporation of USA. There is nothing so big in that, but just to tell them that we also know the conditions. It's very important that we should understand this part. So what I was trying to say is that this so-called getting technology from outside, it never works. They only give you whole thing as a black box. You use it and make money for the company, and it is shared, etc. But at the end of the day, you are no wiser at all. You never actually got that knowledge. They will make sure that you don't get knowledge. So what I am trying to say today here is that they need us as consultants if they want to get out of that Chakravyuh. And then I am further saying that they may get their design team retrained in the process by arranging continuing education programs. In fact, I always encourage it. Whenever I would go as a consultant, I did not solutions as again platforms. I said, your engineers sit with me. I work out the design in their presence, and then we use it. So in the process, they really get the technology also. If they have to design something similar next time, they don't have to again come to me. If they already would know what to do. In fact, I would encourage them to note down everything. In fact, most of the time the practice is, I will be writing everything on the board, and then they will take photograph of each board before it's erased. Okay, so they'll have, if I get filled at 10 boards that day, the 10 pages they would have, and then they can add their own, what should I say, notes on that, and everything becomes this knowledge. In fact, many times they would say, can we record the whole? Now again, see, first I said, why not record it? But then I came to know that when they record that recording, because it's a soft thing, it can be shared knowingly or unknowingly with anybody in the world. So when those people don't want to give us the designs, they take from us in this so-called recording. So again, I'm telling you that you have to learn all these tricks as you go along. Another thing I was telling you here, they may acquire facilities for testing their products as per international standards. So this is what I was telling you. What I did, for example, for philosopher Copeland. I will later on in the slides I will be telling you how many industries help to design in-house test facilities. Now they don't have to send their products abroad. They can not only test their own products, they can now use that to test others and earn some testing money. And so this, of course, the last thing already I told you, the consultant may help the industry to better understand and utilize and import poultry technologies or practices. Because as I was telling you, when they import something, with that comes some kind of manuals. Those manuals are such that only a person like me who is an expert will be able to read in between the lines and tell them what is what. Otherwise, it just remains there. So this is how other things for which a consultant can be used, and then that's very important in the long run. Now, difficulties in addressing needs the industry. It's very important, because anybody I talk to, they say, no, I tried here, and people don't give us consultancy and all that. So let us see now, because if we have to help them, we should understand what they need and then put it in a way that they know now after that. Okay, let's see what. The industry management may not be able to break their needs into executable, well-defined norms. See, what happens is that because these people, most of our industry in India, some technology was taken from somewhere, bought or something, and then they were using that to make money. They really don't know why they are doing what, why that particular machine is working in a particular way, why do we interpret this data, why do we nothing. Okay? So, when they want consultancy from you, they don't even know how to put it in the, because they should understand what you specialize in, and they should also understand what is needed, and therefore they should be able to go to Professor A for something, Professor B for something, C for something, or they may be in different institutions. But for that, they at least need some basic knowledge to be able to break that overall thing into executable portions and engage different consultants for it. In fact, this I realized very early, and during my consultancy, I used to help them actually. So that was not a part of my consultancy project, but I really felt that they need. So I would do that work. I would sit with them for even 2 days, 3 days, okay, and we'll break the whole thing, understand everything, and then into portions and well-defined problems. And then I'll say for this particular problem, we cannot help you, go to such an institute, to such a such professor. Or for this one, we don't have facility to go to such a such place, they will do that. So I would also be doing a lot of what they used to call matchmaking. So it was really matchmaking because I knew what professors are doing in various institutions in the country. And at the same time now I had been with that industry, so I will do that kind of thing. But now most of them, they cannot do themselves at all. So this is, in fact, they need a consultant for this itself. This is more important. This first part is very important, that they should be able to put that, understand the whole thing and then break it up into smaller executable components and then identify the right kind of consultants and approach. Now, a sure way out of this is periodic informal interactions of the engineering faculty with the nearby industries. Now, this is a very important thing which please try to understand, and it is good. What is your starting point? You don't know what industry means, and they don't know what you are capable of doing for them. So, first thing should be you arrange informal kind of workshops. You know, where, for example, I remember when I was here in the department, I did several conferences this time. I would invite a set of industries and just come and have a lunch with us. Okay, and then I have my faculty. So informally, I'll say each industry wala has to just tell what they are looking for. Okay, and we note down it. Then we tell them what we specialize in. And then at the end of that, 1 or 2 persons of industry, 1 or 2 professors from our department, they sit together and then do this thing that I was talking about, that is identify executable portions for which consultancy is available. And not only that, I will also tell them what they will be doing in the process. So it's not simply one way. This is another problem in India. Most of industry, they simply want from professors something ready-made. As like I said, they go to the market, pick up something and pick up something. Now this is not wrong. So in fact, this informal get-togethers, workshops, they really help to first make them come out of this kind of notions that they are here simply to buy something like a supermarket. It's not so. In fact, even let me just tell you, even when they would come to me for noise control of, let us say, a workshop, they won't even know how to put it to me. Because they, in fact, won't even know when I say noise has gone down by 7 decibels, they won't understand what it really means. So I took it on myself. First thing I will do is I go to industry, give them a lecture for 1 hour, free lecture, and that's not a part of consultancy, where I tell them what is noise, how it is measured, what decibels mean, how much reduction can be obtained maximum, and what is will be economical, what is not, and what is the possible kind of things we'll be doing. Okay. So once they have that kind of thing, now then I say then let's go to the problem now. And I analyze their problem in their presence doing loud thinking. There are no secrets. So that they understand how I am thinking and how next time they will be able to break their problem into executable portions. Okay. So invariably, in fact, my wife used to joke about it. So you are the teaching today. I said yes, it's teaching. First day is always teaching. I'll make them understand what is noise first, how it is measured, what it means, etc., etc. Because then only they will be able to define their form of condition. Okay. So now this next is I said this has begun to happen now, courtesy the Indian National Academy of Engineering and the Institution of Engineers in metropolitan cities. They hold this kind of workshop where they invite professors and also they invite people from industry, and they just do this talking, free talking, and then offer, at either lunchtime or the afternoon tea session, then you have a round table kind of discussion, and where everybody is listening to everybody else, and then you are much wiser at the end of the day. So whether it results in a project or not doesn't matter. That at least you understand that by the end of the day, these are the kind of open problems which are needing solution. And then, of course, within the faculty you have discussions to see whether they can join hands to, solve a problem. In fact, it happened many times. For example, I'll just take just one example will help you. The DRDO, Defense Research and Development Organization, their NSPL is Visakhapatnam. They came to us. They said, can you work on noise characterization of marine propellers? Now, uh, up to that time, I had never worked in underwater systems. I knew about acoustics, that is one thing, but I didn't know underwater acoustics, or I didn't know how exactly things happen underwater. Okay, so what I did was, in our department, another assistant professor had joined. He had come from Caltech, and he was in hydrodynamics. He said, that's exactly what we need. So he was in hydrodynamics, he knew about water, and also propellers, etc. Of course, he didn't know anything about acoustics. So he joined hands, and whole thing worked so well that we got, in those days, I'm talking 70s, we got 20 lakhs to start with, and as we proceeded, another project of 20 lakhs, another project of 20 lakhs. So almost for 11 or 12 years we were their consultants. And in the process, we got so much of equipment for our water tunnel and all that, everything. And not only that, my colleague, Professor Vijay Alakari, he was always in demand, from Indian Navy for various things. Like so what I'm trying to say is, other things just follow, because they are all also looking for people within the country who can do something. So invariably, you have to join hands, because every one of us is a specialist. Okay, but we know that what our colleague can do and what he knows what I can do, and then put our heads together and take up the challenge. Yeah, this is another thing, last one. Often there is hesitation or diffidence on the part of engineering faculty to proactively offer their expertise to the industry. This has begun now by means of the consultancy centers and incubation centers in IISc, AICTE, etc. So it was in 70s when we first time a proper center, we call it Center for Scientific Industrial Consultancy, that was put up. And in our meeting of brainstorming, all of us agreed that the center is not just going to act as administrator only for this project. They also have to do, they should call industry, hold those conferences or workshops, and do this map making, which we otherwise are doing at the departmental level in Parliament. Okay, and that has worked very well, because in those workshops, whatever, because notes were kept, photographs were kept, and then some later on recordings are also kept. So at any time when somebody approaches industrial science or something, all they do is they just run some of those things, and they find out, yes, Munjal had come in 4 years ago for a project like this, he might be able to help. When they come to me, then I also have similar kind of things, and then I say, please make sure other person joins me, and then together we can do it. So this kind of thing proactively has to be done by the administration in the institute, so that any time a project and problem is referred to the institute, they should be able to get the right people, pick up the right people, right department in the institute, and constitute a group and jointly take up the problem. Now, I'm going to start with, personal one example, how I turn a handicap into an opportunity. And this is just a model I want to present, because it really works. Now, after graduating in mechanical engineering from Punjab Engineering College, Chandigarh, I joined IIS and did my master's degree in Bengaluru. During the final semester for my dissertation project, I was asked to work on analysis and design of mufflers, although I knew nothing of the course. I decided to do, and all this I covered in the first lecture, so that I'm just giving you some background. I decided to turn this handicap into opportunity. I gave myself a crash course in acoustics and then developed a novel algebraic algorithms analysis of linear dynamical filters, including acoustic filters or mufflers, vibration isolators, and low-pass electrical wave filters. This was a great breakthrough which brought me lectureship in the department on a supernumerary course without any interview. Then now continuing in my research work for PhD, I made use of my algebraic algorithm, developed generalized criteria for synthesis or design of automotive glass mufflers, and multi-degree of freedom vibration isolators. This was a very important thing I want to tell you. I told you that algorithm, given any system, I could able to write the final thing straight away without going to something. And because I was able to do that, I would know what that element, what role it is playing at the end. Or whether that element should have preceded, not followed that element when I am synthesizing the muffler as a set of elements. So in that way, I was able to, what should I say, come out with most general design criteria. For design of vibration isolators, in vibration isolators that even 10 elements put together, 5-degree freedom system and so on. I was able to do that because exactly I know what is going to happen at the end. So in this way, for example, this my paper that I published, a rational synthesis of vibration isolator. So that was not a problem I started with, but because I was making use of electromechanical acoustical analysis, I was able to apply it anywhere I want, whether electrical side, acoustical side, mechanical side, and I was able to do that. So that one paper I published in Journal of Sound and Vibration, till today it is referred. It was 1975, number 22, 47 years. Okay, because nobody else could do, because when you are doing all those calculations, you do the calculation and then you get something, but you don't know now that something is due to exactly what, because we have lost it in between the calculations. Whereas I was doing directly, skipping all the steps, and therefore I was able to come up with this. What I'm trying to say is that this is what happens when you develop knowledge yourself, then you are the master. And that is very, very important thing which I learned, and which later on I try to use every time, and have been exhorting my students to also develop that kind of thing. So that is what really makes you master of what you are doing. And so I'm just saying that I told this work was published in several papers in the British Journal of Sound and Vibration, and I was promoted as assistant professor, and incidentally received also the science medal for young scientists. Now, when I did this, the last line is important. I got this medal from the Prime Minister in 1975 at Warde, where the Indian Science Congress was being held. Now, it was during that my presentation that I got the first consultancy project. I didn't have to go out. Okay? And now that's how I'm going to tell you now how it happened. Now I'm going to talk about my first major consultancy project. So I'm saying here, it was during the Science Congress at Warde that I got my first major consultancy project from the Fertilizer Corporation of India, Sindri. Ironically, it had nothing to do with my specialization of automotive mufflers, but it was on high pressure steam bending silencer design. Okay, now I didn't know anything of this. Okay. This gentleman, he was in the audience when I gave my lecture, award lecture, and immediately after that, he just put his hand on my shoulder. He said, "Young man, would you like to do a project for us?" I said, "Fine, what is it?" Then he told that he had a problem. The problem was very interesting. I never thought those kind of things happen. He says, "We have a steam melting problem." Because what happens is when high pressure steam is being developed in a and then suddenly you find something has happened and that's you cannot close it. The boiler takes 48 hours to stabilize on with that pressure and temperature that you want. And just because you don't want steam, now you can't say close it. You have to vent it out. So he says, whenever something happens in the chemical chambers of processing of fertilizers, now we find that it does not, we don't need steam. So boiler cannot be stopped. if this steam should be vented out. Now imagine, it's very interesting, you will say, what is there, let it go to atmosphere, go on. No, it's not simple. You have 18 kilograms per second. 18 kilograms per second of superheated steam at 200 bars pressure. You know what I'm talking about? It's 200 bars pressure. And when you vent it out, the noise it produces is just unimaginable. You know, to give you, and really what that noise is, because we don't know that part yet. And later on, when we took up the project, we went to Sindri, near Dhamba, and we found there was no bird at all in the atmosphere. No bird, I couldn't find one bird in the whole sky. You know, just wondering, something is missing, something, there's something very strange in that atmosphere. Okay? And then our host, he said, sir, this is the first result of that noise. Even birds not stand. They're dead long ago. Or they are dead, or they vanished. They went away from that. At least they were birds. They had every freedom to go away. Human beings cannot do that because they have to earn their living. Okay? So this is first thing I learned about noise. And second thing was, because whenever steam is not needed, all is closed, okay, on this side, but boiler cannot stop. So the venting stops. And if you happen to be anywhere, let's say the size of this room, let's say, anywhere, you will regret it. You will not get time even to just close your ears. That's the kind of noise. So, wherever venting was taking place, all that area had been cordoned off. So that nobody even by accident happens to be in that area where venting stops. Anyway, so that part I just want to tell you here that most of these things which I think I'm expert now, I didn't even know at that time. And this is what I want to tell you, that it is not a one-way process. It's not that I went as consultant and just helped them around. No, I learned as much as they learned from me. Because I only was a mechanical engineer, I knew about acoustics, I could think, that's all confidence I had, and that's it, nothing more. But I still took up the project and learned everything on the project. And see now. So I'm just telling you, nevertheless, once again I took up the challenge and made use of my knowledge of acoustics, gas dynamics, thermodynamics, and mathematics to develop a multi-system absorptive parallel vapor muffler, schematically of which is shown here. You just see now what first thing that occurred to me, that instead of this expansion taking place from 200 bars to atmospheric pressure, the ratio becomes 200 divided by 1. It's a so high ratio that you have very, very strong oscillating shocks. Okay? And these oscillating shocks, I think it's it. So what I'm trying to tell you is that, I just thought as a mechanical engineer, this basic knowledge, that expansion is taking place 200 to 1 in single step. That is the problem. Why can't I do one thing? Can I break that expansion into a series of partial expansions? So what I did was as follows. Let's look here. Look here this. Now this is a ball. Now I put these perforations here so that this comes and expands through this perforation. So at the throat of those perforations will be sonic flow, So that much pressure drop would have occurred, and then it does not recover because we let it go through sudden expansion like this. So net result is that if let us say this was 200, here it will be 125. Then I have another expansion through these holes, and that brings it to around, let's say, 65 or 70. Then I go to this third one and like this. Okay, so this is just a principle, but I use 7 stages. I use 7 stages of expansion, so that at every stage it will bring down by that ratio 1.87, that is critical ratio. And so that by that time it comes here, all expansion has taken place. And because expansion has taken place in 7 steps, the total noise generated is much less than what it would have been if it had expanded in single stage. Okay? So this is what I learned purely by using the fundamentals. And that later on, in fact, when I went to literature, etc., I found that I was correct. That's what people were doing. Of course, in these matters, nobody publishes, because everything is knowledge and everybody wants to protect it through patents and all that. But one thing was given, and the way I am giving you this, what do I say, a schematic. I got those schematics in the literature. Okay, and that told me I was on the right path. Yes, I must break up the single expansion into a number of expansions. And then whatever noise is generated, first the noise that is generated is much less. The second thing is, because I am making it go through these holes. Okay, so what happens? The noise is always proportional to noise wavelength is proportional to the passage through which it flow is passing. So by making it small holes, frequencies that are generated are very high. Okay, and in that process, 2 things happen. Because I am using, let us say, 5 millimeter holes, and if you find the wavelength is so small, frequency will go to 18,000, 20,000. And our ears can hear from 20 Hertz to 20,000 Hertz. And actually most of it is only between, let's say, 100 to 5,000. So I raise the frequencies beyond audible range. So noise is being generated, but I will not hear it. But my ears don't pick up. My ears as transducers, they have certain dynamic frequency range. And I make use of that to convert this noise to high frequency noise, so that it goes beyond, substantially it goes either the out of range of my ears, or otherwise it high frequency where again it will be audibility will be less. So I'll come to that later, and tomorrow's lecture I will be talking about noise measures. Alright. The next thing is, now I designed a parallel buffer muffler, and the side view of that is this. Okay. So flow is going through this passage, this lever, but actually in what I designed there, I had 18 kilogram per second of steam. Okay. The diameter of the silencer was equal to the height of this room, and length was almost equal to the length of this room. So you can imagine the silencer I am talking about. Okay, and that may also tell you, I was as much surprised what came out. I never thought that my silencer will finally come out to be of this size. Okay, and not only that, even later also, it was a problem because pressure is 200 bars. So imagine those of you who are in structures or stressing or using FEM, etc. I didn't know anything about FEM at that time, and somebody had to do for me those stress calculations to find out what kind of thickness I should use for that. And mind you, the thickness came to be 12 millimeter, steel plate of 12 millimeter thickness. And imagine now if those kind of plates you had to make holes, how to make those holes. Look at the drilling machine, everything at least special. In fact, the whole thing was a big learning process, and I enjoyed it because everything I was also learning for the first time as they were learning, and I was being paid for it. Why not? It's a good situation that I learned at their expense. Okay, So, but this actually became a model later also. Most of the time, I would take up the problems to learn. Okay? And every time I picked up some new knowledge and then I use it. There also I'm going to tell you what I learned from there, I used for how many consultancy projects later. And all that was almost free. I mean, in the sense, within half a day, I was able to design those configurations. This took me 6 months. Okay. But then, I mean, now after that, I was able to half day or 1 day maximum. Alright. Anyway, what I want to tell you is that at higher frequencies, these parallel buffer mufflers, they are much more useful. In other words, in less length of the muffler, you can get more reduction. And let me tell you, I mean, finally, without going into further details, this silencer that I designed gave me 53 decibels of noise reduction. You know, it came from 155 to 102. 102 is also high noise, but that high noise is a very different level. Let me just tell you that every 10-degree reduction makes us feel the noise as come to 50%. Perception-wise, every 10-degree reduction means halving. Okay. So another 10 degree and 30 degree when I say 10 plus 10, that means half into half and 1 by 4. So it has come to 25%. And like that, 1 by 8, etc. etc. So when I say 50, noise came to less than 1%. Okay. But even that 1%, let me tell you, was 102, which is equal to a truck noise of the truck without silencer. That's the fact. Even after that, noise was equal to a truck without silencer. But good thing was that now it was no longer injurious to health. Nobody would lose his hearing. In fact, earlier there were many cases, where people had become hard of hearing and they were useless for them. In fact, they were trying to send them away as unfit for this. Unfortunately, the unions took it up that the damage has occurred on the job. You can't say this man is useless. His hearing has been taken away by the industry. So it became an issue of a different kind later. And in fact, that in one way, that is how the Central Pollution Control Board set up a national committee for noise pollution control. Again, I was asked to chair that. I was a chairman for 18 years on that. I'll tell you later tomorrow. But all I'm trying to say is that every time we took up a challenge, we learned so much, we encountered new kind of problems, learned new things, and later on they came to be used in entirely different way of leading other projects and so on. So, one thing that I want to tell you in summary from this slide is that have confidence in yourself. Say, yes, I don't know today, but I am going to learn. That's the kind of spirit with which you should take up new projects. Just tell yourself, yes, I'll do it. At least I know somebody who can help me in the beginning. Okay? Or I know the source. In those days I didn't even know about the source. Now you are lucky because now we have internet, etc. And in 2 hours of search on the internet, you'll be able to get all the sources and everything. All you have to do is now spend time to learn. Okay? But we didn't have that. So you needed much higher level of confidence to take up projects in those days. But we did it, and as I'm going to tell you, that during my life, apart from doing the best of research and publishing papers and getting awards, I still did 125 projects of consultancy. And every project was different. So what I'm trying to say is we are capable of doing all that. Only thing is we have to develop that confidence all the time. Remind yourself, I can do it. Yes, I can do it. I don't know today, but I will know tomorrow. I'll do it. So it is with that kind of thing that you really can become a good consultant. And it's very nice. The feeling is great. At the end of the day, you really love yourself. You say, yes, I can do it. So it's not just in sports that you see people, doing this. You can also do internally, for your own research. I have done that. All right. Next. Now, I'm just continuing with that one. High pressure steam or gas venting diffuser cum silencer system. So at the Sindri plant, we achieved a noise reduction of more than 50 decibel during venting of 18 kg per second of superheated steam at 200 bar pressure. The basic physical principles used in the design are as follows. Reducing pressure from 200 bars to 1 bar in several stages should generate much less redundant noise than the single stage expansion, which would result in strong oscillating shocks. And the multiple jets emerging from small diameter holes produces relatively weaker and high frequency noise that can be easily carried up the loop. The same or similar technology was applied later for design of mufflers for high pressure venting of steam for the Bharat Heavy Electricals Limited, Trichy, during 79. Vent silencers for the Fluid Control Research Institute, Palgraf, area of Coimbatore, and third, multi-stage diffusers and silencers and development of graphic user interface for the BHA Advanced Research Project Division, Delhi. Silencers for the high pressure safety valves and vents for the BHA Carpet R&D, Hyderabad. And several similar diffuser cum silencer systems for the PR acoustical engineering works, which in fact this company has been having as consultant for the last 25 years. Okay. So what I was trying to tell you is that I was able to not only give designs, but also I gave them a graphic user interface that I developed and gave it to them as almost my case. It was not a part of it. I said, no, you go on designing yourself in Trichy, and what they do is now they do everything, and they send me the final thing that this was the problem. This finding what shall we start fabricating. So only for coming or they are independent. Because I like to make them independent, because I don't want to hold them on to me. They should be on their own, and that really helps. Because I also have the pleasure of going to a different project rather than continuing with that. Now, coming to this parallel baffle dissipating mufflers, it's not just for this high pressure steam venting. These mufflers or silencers convert or dissipate acoustic energy into heat by means of baffles made of highly porous foam or fibrous material. And the material that we are talking of is porosity of more than 95%, and if it's fibrous, the fibers will be something like a 10-20 micron size. You have to understand. You don't need. I will not go into details. All I want to tell you is that all of you know that when, let us say, there is a flow through capillaries, so you have this boundary layer velocity has to be 0. Another this side also has to be 0, and within that it goes to maximum and then 0. So you have very high pressure, say velocity gradients. Okay. And then you know that basically shear stress is mu du by dy. So it is du is the velocity whatever it is, but dy we are almost making 0, going to 10 micron. So denominator is so small that I get very large viscous stresses. And so acoustic waves, when they are trying to go through them, they encounter so much of high viscosity that this acoustic energy, potential energy, gets converted into heat, which is irreversible process, and therefore energy is taken care of. So you don't have to worry that if somebody asks me that in my industry, you say that much energy you are going to convert into heat, you are not going to come to the system. So I can tell that that when it comes to heat, the scale is entirely different. In fact, I like to share with you that the answer in a more technical way. I said if all the noise that is being produced in the world, all the noise that is being produced in the world at this point of time was harnessed and we use it to boil water, we'll be able to boil only half a glass of water. All the acoustic energy harnessed from the noise of the world is enough only to boil half a glass of water. So what I'm trying to say is the heat that is produced is negligible. Okay, so main thing is we take out dissipated matter, just dissipated for all purposes, it is taken away from the system, and that's what matters. Alright. Now these muffler silencers convert and dissipate acoustic energy to heat by means of baffles made of highly porous foam or fibrous materials. They work on the principle that it is visible to use parallel louvers instead of an acoustically lined, it's a mistake, acoustically lined duct with a single flow passage of length is called the astronomy. And let me not go into this. Okay. Now, the more the number of louvers, the less the half passage width, the glass are outer minus are inner by 2. However, there would be the accompanying passage of higher back pressure against which the fan or blower will have to. Now I'm talking about heating, ventilation, air conditioning systems. Okay, there would be the accompanying penalty of higher back pressure against which the fan or blower will have to work. And on the larger the size and cost, there lies a challenge for the muffler designer acoustic. Now this is, I just want to tell you that we now have 3 problems. A reduction of noise, reducing the back pressure, otherwise my fan will not be able to push that kind of air to the system because back pressure increases. And third is that size of the muffler will go on increasing, and that costs you a lot of money. Okay. Let me tell you one thing. Many times you will have non-technical problems in these problems. A particular place, I'm not talking about Sibiri and all that. Those were the days, in 70s. We used to import everything. And this technology used to come from Russia. And when I gave the design to the government or some defense project, you wouldn't believe that project could not be implemented. And those people will not even talk to me. I mean, they paid me fees, that's fine. But after that, they wouldn't like to share with me what happened to the performance of that software. 2 years later, I came to know from a third, fourth person that as soon as they found out that this is the kind of performance and this silencer that Munjal has designed will cost only 1/7 of the cost that they were otherwise having to pay. Okay? Those people twisted media in the government's hands, and they won't let them use this. My designs were just not used, and everybody was already afraid to talk about it. That who twisted whose hands or arms. So I'm just telling you that you also have situations of that kind. Okay, for which you can't do anything. Later on, I'll tell you at least something that where we were able to, break that kind of barrier. For example, the lining side design for submarines, we were able to save 20 crores of rupees on each submarine. And still that government brought, and finally they had to allow. So, you can always fight that, and sometimes it works. Alright, now just continuing with that, I'm just saying that parallel buffer mufflers. Now, over the years, parallel mufflers have been designed by us for exhaust system of the Transonic Cascade Tunnel of CSIR near Bengaluru, the ISRO Acoustic Test Facility exhaust system at near Bengaluru, gas turbines at DHA of Ranipet, gas turbine engine at GTR in Bengaluru. GTR means gas turbines at the cell. And Alstom gas turbines at Forest India, Bengaluru, and heating, ventilation, air conditioning systems of Spectrum Industries, Mumbai, Convention Center for Messrs. Siddhavadkar and Thakur of Hyderabad, and gas turbine inlet for Aqua Industries, Calcutta. Now we come to a little different field, intake and exhaust noise of IC engines. And that is my bread and butter, that's my field of research. For IC engines, we use non-dissipative. For IC engines, we use non-dissipative or reactive mufflers that work on a principle of impedance mismatch. Now, this is a very important thing I want to tell you. By example, all of you know that if somebody is drowning in the water and he shouts for help, you cannot hear that he is underwater. And not only that, you shout instructions, he cannot hear you properly because of impedance mismatch. Characteristic impedance, which is product of density and sound speed, rho into c. So rho into c of air is around 400 units of credits, whereas for water it is several thousands times. So the impedance mismatch is so much, neither sound can go from air to water, nor it can come from water to air. Same principle we use. Here now, their medium density was like that, but their medium is same, but we use the area sudden changes, sudden expansions and contractions. We have, in other words, series of impedance mismatches, much lighter or weaker than that, but together they can really give you good noise reduction. That's a general principle, but actually mathematically it's much more difficult. Now, sudden area discontinuities provide a sharp jump in characteristic impedance, thereby reflecting a portion of the incoming acoustic power back to the source. Efficient muffler configurations make use of multi-pole perforates carrying bias flow as well as grazing flow. One-dimensional or plane wave flow property analysis of reactive mufflers is carried out using the transfer matrix method or matrix and approach. Basically, we are using most of the time I am using linear algebra and things like this, including Eigen analysis. It is not so accurate as a 3D finite element method, but it is good enough for design purposes. The back pressure may be estimated by means, again the back pressure I don't use computational fluid dynamics because that itself becomes a big headache. So I use this, the back pressure may be estimated by means of the lump flow resistance network. Okay, it is much more convenient than the computational fluid dynamics. Now this is another thing that's very important, that when you are working on consultancy, now you don't want the kind of exactness that will be only given by computational fluid dynamics or FEM, etc. You know that for design purposes, certain basic concepts are fine. And so every time, everywhere, I had to develop simpler methods. And that again became, what should I say, contribution worth publishing. And I will publish many papers because journals are there who need this kind of thing. And that was also useful. So I got the research papers as well as the satisfaction of delivering on the consultancy project. Now, just to tell you now, this is how a typical exhaust muffler for IC engines, etc. looks like. The flow is coming like this. Now, a part of this will get out of this to this holes there, and a part of that, so that's what we call bias flow, and a part of that continues as grazing flow, comes here, this is closed, but then this is open, so it gets in here. Already what had got out here, part of that comes in here and mixes. Then together they continue, come out here, meet this dead end here, and this is that elliptic small chamber, and then again come here and go through this. Part of that already had got out here can come in, other is coming in here, and finally here. So it's very interesting. Of course, right now I'm able to tell you all that. Let me tell you, it took us almost 15 years, to break this point, come out with a complete analysis of this. And this is what I was telling you. That paper was the best paper in the world. Of course, we got award from this concept. But my students and I, we really struggled for really long years. And that is where it is important that we should be able to have very nice fundamentals so that we continue. So what I did was I started this work in early 70s. When I succeeded, it was 1985. So I kept the kind of. But in between, I had guided 4 PhD students. So I was able to break this complex problem into smaller, well-defined problems, so that each student could get his degree. Okay, so he poor fellow cannot get, he has come to me for 3-4 years and he wants PhD. Okay, so it was my business to be able to break it up in such a way that it serves his purpose for PhD. At the same time, I have in mind all the time what I finally want. Okay, so this is where you have to have very clear idea of what is going on and have confidence in yourself, because if you don't have confidence, your student cannot have confidence. They really look up to you. That's, but then I also must say that I was really lucky to test with some very good students. Of course, after then they think it was a lot of things. But anyway, main thing is that I was talking to you about the concept of mastermind, and it really works. Okay, and particularly this final thing that finally happened was one particular Rajendra, he had come to me from Osmania University, Hyderabad, under the quality improvement program. Okay? And that is how finally he succeeded. But what I want to tell you, the physical principle is very interesting. The flow is going in this direction, it's carrying waves. Now, it encounters these holes, they have their acoustic perforated impedances. At the same time, it has another path this way. So you have cancellation of waves by using the right kind of phase cancellation. Again, I am telling you this, but at that time you knew nothing about it. It's only later that we analyze what was going on, and then this theory came later. The actual analysis had to come first. That was all a question of mathematics. We simply used eigenanalysis. We wrote a number of equations simultaneously and then solved it as an eigenvalue problem. And that is how we were able to relate the state variables pressure and velocity here with finding what is here. And then finding. Okay. So this just I cannot go deeper into this. Okay, now just to give you an idea that once we develop, over the last 4 decades, the intake or exhaust mufflers have been designed by us, Telco or Tata Motors in Pune, Reva vehicle of Industries in Bengaluru, cycles of Eicher Royal Enfield Chennai, hybrid electric and dissipating mufflers of Owens Corning, Mumbai, and Mahindra, Nashik, and Chennai. Chennai Mahindra Research Valley, and go to Tamil side. Okay, and then forklift engine of Voltas in Thane, escorts tractors Vidarbha, single cylinder Eicher tractor of Cafe Mandiji in Madhya Pradesh, locomotive engine of General Electric India Tech Center in Bengaluru, engine of the LG equipment in Coimbatore, tractor engine of Cafe R&D in Chennai, automotive exhaust systems of Malaysia Mission Control Technologies, intake silencers for Samveni battery charging systems for Kirloskar Oil and Gas in Pune, again exhaust silencers for Samveni battery charging. So once we had that analysis, we had those programs, everything ready, and then it didn't take us much. We could take up so many consultancy projects for the years because already we had worked, we knew something, and that was not with us. So then it's all a question of giving service to various companies. All right. Now another thing that's very important in the country, that every industry has captive diesel generator set. You cannot depend on the line power. Okay? But then this diesel generator set makes not. In India, because of shortage of line power and the unreliability of electrical power transmission system, most of the industries make use of captive diesel generator sets. the Central Pollution Control Board Executive Wing of the Ministry of Environment and Forests, on the advice of the National Committee for Noise Pollution Control, has issued gazette notifications, for limiting the noise generated by the DP sets or DP power stations. In fact, I was chairman of this committee for 18 years. During my tenure, on advice of our NCNPC, the Ministry of Environment and Forests issued gazette notifications for limiting the noise of diesel generator sets, portable kerosene generators, four-wheeler as well as two-wheeler vehicles, and firecrackers, public address systems, and all. You know how start of this thing was very interesting. You may not talk to them for about 1.5 hours. And I could see from the faces, for most of them, it's the first time they were hearing about what is noise, how it can be measured, how it can be controlled, etc. And then it was followed by 2.5 hours of discussion. I still remember that whole thing, because all so finally we had to stop, mainly because we had been getting calls from the assistants that this flight is missing or this will not be able to catch, only because of flight problems. Otherwise they were ready to listen. And one thing, what happened as a part of that is 1 month later I get a letter requesting me to set up this committee and chair this committee. So this committee would change every 2 years, but they requested me to continue. I remained chairman for 18 years. Okay? And during that time, all these gazette notifications were issued, and those are now mandatory. For example, if you make a diesel generator set, you are responsible for the noise it generates, and also give acoustic enclosure such that noise outside is not more than 75%. Okay, in fact, I'll come to that later. So do that. I hope I'm not exceeding time.
No, sir.
Okay, continue this. I will not cover too much, but I want to cover that because everybody is expecting that. Yes. Now, a number of things I can tell you from this slide. Can everybody see this, or is it faint? Can you see this? Okay. Now you just see here. The problem is a pump or compressor. It's a large compressor, and it's getting its power from an engine. So we call it engine compressor set. And now when it's running, it has to suck air. For this engine. So this air inlet is here, and it's guided in such a way that all the air goes and impinges on the hot surfaces of the engine, takes that heat, and then again not simply collect it within this, but then we again help it to the forced exhaust system here, so that this air is taken out. Okay. So to make sure, though the air is going like this, but the noise goes both ways. So when air is going like this, engine noise also is coming here, and we don't want to hear that. So we need a parallel buffer muffler here. Again, finally exhaust is here, but again sound will go this way as well as this side. And again we need a parallel buffer muffler here. This is only part of the story. Other is that unbalanced forces from the engine and the compressor, they have to be isolated. So we have here isolator springs, anti-vibration mounts. Okay? And to make sure that there is no relative unbalance or wobbling, so we use a common steel plate, okay, which is having compressor, and this in such a way that there is no, it's a balanced on site. It's not even 3 microns of differences there. Okay, and then the unbalanced forces, part of that is transmitted here, and it will travel like this as structure bound sound and disturb everybody else. For example, I can just tell you here, if we had put a setup here, it will excite the floor into vibration, and then travel this floor in vibration waves travel and reflection waves. And because the wall is joining the floor, the wall is set into vibration. And then same wall to the second other floor is touching, so that goes to that floor and so on. You won't believe in a multi-story building, every floor will be set into vibration by this fellow sitting in the underground. Do you think that you have done a good job? No. In fact, this thing was discovered in a very interesting way on a ship when they were going something, and then they increased the speed of the engine. And at some speed, something very interesting happened. The big, that anchoring chain, which was 10 tons heavy, was on the deck. And there it started jumping as if like a ghost. Because they could only suddenly see that happening, and they couldn't understand why. They could never imagine it's because of the unbalanced forces at the bottom of the ship, which is doing this. So what I'm saying, this phenomenon of structure bound sound is very important, and after it was discovered like that and in a dramatic way, a lot of research has been done on it. And so, but we don't have to go so much into that. All we have to do is we make sure that these forces, by these isolators, 90 to 95% is isolated, only 5 to 10% come to the ground. Not only that, when they travel, we again make viscoelastic pads here. You see this? So that now there is no coupling between what is happening here and what is happening here. Again now, because pumper compressor is taking the air and then delivering it, so again this is set into vibration. So we use this again viscoelastic bellows here. Again another set of bellows here. Not only that, here again it is supported on this. So we use this foam rubber sleeves to seal the another openings. Okay. So this is all on the vibration side. Then we have to make sure that the noise, whatever is produced here, that should not go. So we make use of a lining of sound absorbing materials, and they have impervious enclosure wall on this side and highly perforated plate here, such that the sound gets absorbed in this. At the same time, mechanically this is supported. So this perforated plate plays two roles. That is to provide the acoustic interaction, at the same time mechanical isolation. So I want to just tell you here that this is one field where I have done maximum number of projects, because these are the data sets are everywhere. People need a political closure. So we found soon that there was a lot of passing the buck. People say, no, it's not my job. What if I am doing it? Okay. So then the person who supplies the engine, he said, no, I am into engine. I am selling engine. It's their business what they do with it. So we found out soon that no, this business is not work. So what we did was in that committee, in the gazette notification, we have put the onus of designing, fabricating and supplying the acoustic enclosure along with the engine. This man now cannot sell the engine without acoustic enclosure. You understand? The onus is on him. And after that, suddenly everybody is behaving. We were able to discipline the whole nation through that gazette notification. And of course, even in the gazette notifications, I had as chairman of the committee, a lot of pressure was brought on to me by various lobbies and all that. Even government ministers joined, those investigators. No, please, don't do that. You are actually doing something to upset the whole economy of the country. I mean, all other big things were thrown at me. Okay? Yes. So anyway, it took a lot of time to convince them. We had a number of meetings with industry people and finally convinced them that it would work. And more than anything, it has to be done. For example, if I have every right to use a DG set to give myself uninterrupted power. But why should my neighbor suffer? What has he done? You know, basic logic, by please try to see. I have every right to live in my house the way I want, but I have no business to disturb my neighbor. So these are basic principles of environmental control. So, and this took several years to happen, but now everything is under control. And now, in fact, the people are so careful about everything. And now they come to me only in the beginning many times, because even acoustic control is not sufficient. You know, because there are other gazette notifications which says, do what you want. But when you are having celebration at home, the noise at your neighbor's house shall not exceed by more than 10 decibels. If it exceeds, he has the right to call the police and make you stop the celebration. And it has been done in Bengaluru. In Bengaluru, you know, people are quite educated and they understand and you know they listen. Because you know their whole society is different. Because so much money has come from all over the world, and so many multinational companies are there now. So that culture has also come. That it has to be done. There is no question of you getting out of. In fact, you won't believe, you know, there was one day I was woken up at maybe 1 a.m. or 2 a.m. by somebody I had never met before. And then he introduced himself as proprietor of some talkies, a movie theater in Mysore. And he was the whole thing was making, he said was making so much noise that the houses nearby, the walls were shaking. And those people went to the deputy commissioner of that area and he simply said that you have just stop. You will not operate the theater from tomorrow. And then this man calculates suddenly that he will be losing 3 lakhs of rupees per day. So he could not even wait for the warning. He just from Mysore, came to Institute of Science, met over the PRO, he was directed on to me, and then he wakes me up at that, you know, and said, please do something. So anyway, what I'm trying to say is that when these people find out that they have to do it, then they do it. Okay? So this is very important in India. We have been able to control most of this thing only through these gazette notifications which are mandatory. You know that you don't believe the pollution control board man and simply measure this, show you this rule and stop the factory, irrespective of big factory is. And it has been done. So please understand, you know, that though people like me had to go through a lot of stress and all that those days, you know, fighting these lobbies and with ministerial pressure and all that. But finally, country is having some kind of discipline. Okay, and that's very important. Somebody has to do it. Alright, so I was just telling you, over the last 20 years, consultancy has been provided for design of acoustic enclosures for naval science and technology laboratories, Visakhapatnam, ITC Petroma in Chennai, Ascon Jyoti Bengaluru, the packaging and printing unit of ITC Chennai, King High Vacuum Bengaluru, Brigade Enterprises Bengaluru, Optima Power Solutions Bengaluru, Sine Wave Unit Bengaluru, ETV Power Solar and Basic Technology Bengaluru, Portable Genset for Central Pressure Control Board Delhi, noise control of captive power station. This was very interesting because everything was done by gazette notification by CPC. So first thing they realized that their own BE set was making a lot of noise. So in fact just after that particular meeting, and they said, please now, before you go back to Bengaluru, you have to design for us. Otherwise they will always come and say your own set is making noise. So this is how I did for them. And noise control of captive power stations for Ascom generators in Bengaluru. Then mounted genset for research and development engineers, it's a DRDO lab, Pune. Then compact surveillance for DG sets of Koyal, Kirloskar organization in Pune. And estimation design optimization buffers for Optima, Bengaluru. And these are some actually the details. Alright. Now this thing consultancy was provided for single cylinder two-stroke cycle. Now why you will say why different? It's a very different thing because for the two-wheeler vehicle engines, silencing is coupled with tuning of the exhaust system for better spending and warranty efficiency. And this requires time-dependent simulation of the thermodynamic cycle and gas dynamics of the exhaust system simultaneously. So consultancy services are provided for. Again now, this is a very new field for us. That we learned and try to develop those programs and then gain consultancy to simulation for simulation and development of a moped engine for Sundaram plate and Kosu. L35 engine simulation development for the rally ATM Mumbai. And moped silencing for TVS Suzuki Kosu. And then also I have helped in the design of in-house facilities. You might be wondering how I could do so many projects together. The secret I involve my students all the time. Involve my students, and it was a win-win situation. Two things I did. First, taught them what needs to be done. That was part of my duty anyway as a teacher. Then I shared part of the consultancy fee that I got with the students. So part of the scholarship they got with the extra. Third, because they worked for this thing, they became known to the industries, and those industries were waiting for them to graduate and absorb them as engineers. So it was a win-win situation for everybody. Yeah. So this is another thing because I was giving an example of philosopher Copeland, where I designed for them a reservation channel. So facilities are designed, in-house test facilities for handicap chambers, reservation chambers, and test facilities as per international standards. And I'm writing here in a pioneering effort in this direction. Consultancy services are provided for design, fabrication, and certification of any handicap chamber for testing of automobiles at Telco, which is now Tata Motors, Pune. Noise test laboratory for hermetically sealed compressed for philosopher Copeland that I was talking about, Karad. Reverberation suite for acoustic testing of facades, Abdul Pune, and Bombay. Reservation room for work to India, Pune. Acoustic test facilities for aircraft tires of MRF limitation. This in fact is still project going on. The last we consulted to MRF Chennai for the last 6 years for aircraft tires, and you know the project is completed. And they are putting up the biggest handicap chamber where the complete vehicle can get in, get tested, simulating the pass-by noise conditions, and finally they get the certification accordingly. So this is the biggest facility that's coming in, bigger than Tata. So Tata had also designed a new, but now this is the biggest in Chennai. Yeah. Then acoustic test facilities for naval science and technology laboratory in Visakhapatnam. Air acoustic center for Ishwar, that is the Indian Society for Heating, Refrigeration, Air Conditioning in Bengaluru. Design of noise testing laboratory at AICTE Pune. Design of acoustic test facilities for hydraulic machinery of Genesis Hydraulics in Hyderabad. Air acoustic testing facility for air treatment units at Carrier in Noida. Engine noise test cell at Engineering Research Center of Tata Motors. And this is another thing now, very important, all of you should know. that if you want to set up industry, you have to do what is known as environmental impact assessment (EIA). Without that, you cannot get clearance from the Ministry of Environment and Forest to put up industry. So you have to make sure that you satisfy them that you will not be polluting the air, you will not be polluting the water, you will not be producing too much noise, and you will not spoil the ecology of the place. So this whole thing is done in an EIA study. So all of you now have to learn the concept if you want to get into business. But more than that, there is a big opportunity for youngsters sitting here. That if you can specialize in environmental impact assessment, there is a lot of work waiting for you. There are very few people in the whole country. Now I can count them all with the finger in one hand. So everybody is waiting for advice on EIA. It's a very good opportunity. Anyway, I just want to tell you here, the following projects were carried out for the environmental impact assessment or estimation. Environmental noise of St. Joseph's College in Bengaluru. Environmental impact assessment for the model rubber root factory for rubber board in Kottayam. Acoustic impact of turbo compressor of Bengaluru. Acoustic EIA for power press for Sansera Engineers in Bengaluru. These are just a few. Other thing is that many times companies they engage consultants outside India, but finally when it is done, somebody has to certify. So again, the companies are doing a lot of certification for them, like a wetting design for acoustic treatment of hangar for DP company at the airport in Nagpur, and wetting of acoustic design a simulator block again for aircraft testing. Shirokar company Goa, an acoustic audit of the indoor stadium at Connecticut, because I don't know how to pronounce, for National Game Secretariat Tiruvallur, and technical review of the Sonics acoustic design of the Nimhans Seminar Hall for the investment consultants in Bengaluru. Now, these are just some miscellaneous consultancy projects which have been done. All relatively big projects, okay, instead of putting them separate and putting this list, I just go through them fast. Design of a motor cooling roll silencer for BHE of Bhopal. Noise control of the chiller plant for Brigade Enterprises in Bengaluru. Designing a quieter car. This is a very prestigious thing. Designing Indica, first car for quietness. You know, that was for me the biggest project. Because Tatas up to that time, they were known only for trucks. And people thought that Tatas cannot make small cars. And one of the main problem was noise. Okay, so I was able to help them, you know, in designing that Indica. In fact, when I said I had to, I just told them that whenever your design team sits together and takes decisions, you just let me be there. That's all. I will tell you out of various options, one for this particular option is required. That's all. Always for any situation, you can do so many things. Okay, and tell them out of that. Okay, choose this one. If these are the kind of bearings you can use, it will be right. If these are the kind of roads you can do, it will be better. If this is the kind of suspension you can have, it will be better. So all I did was, all the time, I helped the design team to select the right option from available options. So in fact, at the end of the project, my file did not have more than 30 pages. You know, advice. So everything was done by them. And I was only helping them to make sure that the car that only is built, it is quiet. And mind you, it was not quite to start with. So we had to do some fine tuning. But within 6 months of the first prototype, the Indica could satisfy the national standards in noise control. The noise control of the heating ventilation air conditioning systems for Motorola in India. Noise control of chillers for climate control technology in Bengaluru. The noise vibration harshness solutions for automobile and white goods industry for Messrs. Paracord Products Bosu. The noise suppression systems for Laser Tech Center DRDO Delhi. The noise suppression mechanism for air turbine starter rig at GTR Bengaluru. And it's interesting, for example, this particular application. I cannot tell you anything about it, very confidential about it. But all I am trying to say is that basically they are able to shoot down using laser beam anything coming after some radius. But what they do in their system produces so much noise that you cannot afford to do that. So I just designed silencers for them in such a way that the basic operation is not compromised. At the same time, noise is less. And again, continuing that list, noise control of cooler compressor thermal imager at IICTE. This is very, again, these are very important small projects. Basically, what happens is you are sitting in a forest and you know that enemy has already come into that forest and you want to detect them without taking light. So you use infrared sensors to detect. But again, the way that sensor works, it makes noise. So on one side you want to detect your enemy, but before that, from your noise you will be giving out your position to them. So that is useless. So we only help them for building in the making it white. Then vibration noise control measures for high-tech forgings in Bengaluru. Noise control of the high pressure turbine heat transfer rig of BPI at Bengaluru. Then design of Helmholtz resonator lining for helicopter cabin noise suppression for HCL Bengaluru. Design of acoustic strut lining for, this is the big thing I was telling you. It took us 20 years, and finally it was all work. So now at least I can have the pleasure of, saying that I could make my survey invisible. Then reducing noise and vibration level of marine gearbox for Walchand Industries Pune. Noise studies, attenuation of noise of steam turbine at BHP Rasipuram division in Hyderabad. Air noise measurement control for another Chennai. The in-house intensive training course on muffler acoustics for Malaysia, Lean Mobility. This is an international company. So I basically took the help of another PhD student. Two of us together offered a 76-hour course on another book, Acoustics of Cuts and Mufflers, and so that they get all the knowledge, design silencers for themselves. And some projects that we carried out abroad, I will find on sabbatical at the Institute for Technical Universities in the Technical University of Berlin. During 1780, I studied the railway direction and identified mechanisms of the railway noise and established the need for randomizing the distances between the sleepers and the roof. Carried out 2 projects for Clifton Volkswagen Germany from IISc Bengaluru for development of perforated element automobile mufflers. This path got me a couple of national as well as international awards and led to publication of monograph of while working as a visitor at the University of Calgary in Canada during 86-87, I consulted with Nova Research Corporation for acoustic modeling of their multi-branch gas networks with intermediate booster compressors or pumps so as to avoid building up of oscillations when a new line is added to the existing gas turbine. This is very interesting. When they approached me, they told me a small story, and they said that when they wanted to do this work on this, they were not allowed because they said it's too costly and there is no need for this. These people try to tell them that if you don't do that analysis, a resonance may occur someday and the whole system will blast. Right? Nobody listened to them. This is the usual human tendency or work. And one day, that company which has a gas network in Calgary, they just gave a connection to a new locality that came up. Just a line was added. And that changed the natural frequency, or one of the natural frequencies of the network. And next day when they started, it just blew up. And when I say blew up, the damage even before that will be contained, geosite studies and even before it contained, it was sufficient to run all the do all the R&D work for next 5 years. If they wanted to, they didn't want to do it. But now even the first damage was equal to the expense they would have made done for 5 years of R&D work. Anyway, so what I'm trying to say, when I went there, I was Calgary. They came to know that I'm visiting them. Immediately they came to me and then said, please, that means you are right from here, can we have? And I mean, for me also, other than basic knowledge, I knew nothing about this. But then, we worked with them and developed not only a complete mathematical model for the network, we also told them what needs to be done or can be done right at that design stage. And that was a great thing. That not only they gave all the consultancy money to my professor, which of course he shared with me, okay, but insisted that when I move out, they would like to give me the first class tickets, to go back. I mean, just as a, thanks. But main thing was in the whole process, I had learned so much because at that time I knew nothing, but I came to know it's so important. Now let me tell you, when I came back, I contacted Indian Oil and told them the story and told them that maybe I can help now train your people into doing these calculations and avoiding those measurements. You can see now that till today they have done nothing. Because that's how we work. Now then, I was a member of the Research Advisory Council for the Western Industries Scotland for 3 years, and that was really not just an honor, but also they gave me good fitting fee. And I also consulted Ford Motor Company in Michigan during 94-95 to develop design guidelines for the intake systems of automobiles, and did some pioneering work on vibropors, hoses and bellows, and noise reduction and climate control systems of automobiles. Finally, I just want to tell you I've carried out over 125 consultancy projects, and my experience has shown that industrial consultancy can be win-win situation for the industry as well as the consulting faculty. If the industry can do a little homework, it's very important. Now, this is what's missing in India. If the industry can do a little homework so as to define their problem precisely for presentation to the prospective faculty consultants according to their strengths and weaknesses, and work closely with the consultants, they'll be able to get the best of it. That's what I was telling you. Our consultancy center did all that, and now you also can think about it, do some brainstorming together, and set up those basic meetings and learn from each other and take notes. And I'm sure you will be able to break the ice and some projects can be done. At the end, they will get not only cost-effective solutions to their problems, but also pick up some new knowledge and develop an ongoing relationship for brainstorming on the new developments in that field from time to time. And just the concluding advice on this is that on their part, the engineering faculty should develop a habit or hobby of updating their knowledge continually by self-study, challenge themselves to solve practical problems and learn to enjoy their research work rather than looking at it as a job. Approach a new consultancy project as an opportunity to learn something new, thereby making a permanent addition to their knowledge base. And encourage their graduate and research students to inculcate study in order to develop self-confidence, which is a prerequisite for research, development, innovation, as well as industrial excellence. And this is just telling you that the book that I wrote arising out of economic consultancy. This is called Noise and Vibration Control, published by IICTE and World Science Publishers. Okay. The total material for the following slides has been extracted from my textbook, and its software Indian edition is now available. Earlier, it was hardcover international edition, it was $65. It comes to almost 5,500 rupees. But now it's just $8.95. And not only that, our Tata Motors, Tata bookstores in IAS, they give you further 20% discount. So it's just 600 rupees or something, which every student should have. In fact, my advice to everybody, industry also, every designer should have it on his, because in this book, I have not used any mathematics. If everything is done in such a way that anybody who is just a basic engineer can read, understand, all formulae are given, graphs, figures, tables, everything, with solved examples taken from industry, everything is there. So that I just thought, I'll just tell you about. And finally, the special features of the book are, it's based on my 4 decades experience in postgraduate teaching of noise evaluation, as well as industrial disciplines. The stress is on physical concepts, graphs, tables, formulae, solved examples, and unsolved exercises now from industry. It eschews mathematical derivations so as to make the book suitable for self-study. The book is directed as much to the industrial and automobile engineers and designers as to the senior undergraduate students. It fulfills the requirement of an elective 3-credit course for senior undergraduate students from mechanical. It is recognized by AICTE. Thank you. Sorry, I think I need more time, but I thought that. Yeah.
Thank you, sir. If you have any questions or any discussion, please ask.
Let me sip of water. Yes, please.
Any questions?
Good afternoon, sir.
Yeah.
Sir, yesterday when you elaborated about how Indian Institute of Science was a vision of Mr. Tata, since you are here influencing people like us, what's your vision, sir?
What is mine?
What is your vision? Apart from acoustics and noise control and stuff.
I think over the last 3 days, that's what I've been doing, telling you all. And that part is over there because I'm now 77 already. Okay, that's reminding us rather than have no billion fund. But anyway, I've generally been telling you that it has, looking back, it has been great innings. And all, it so happened as I've been telling you again and again, just things happen. Here also I didn't plan for any project. Everything just kept happening. All I did was took everything as a challenge rather than saying I don't. This one thing is very important I want to share with you. I have one thing that you take away from my lectures. It is have faith in yourself. And don't let the opportunities go simply say, no, I don't. Because everybody who knows today, he did not know one day. Everybody has to start with it. Whatever knowledge you have, getting there, you know, because it started somewhere. Somebody developed that knowledge, right? So tell yourself, why can't that be me? I'll do it. And every time you do something, that gives you confidence for the next one, for the next one. And so, that's why in the last 2 days also, I told you how many times I was asked to work on something which wasn't done in me. But it should be done. Main thing is, we are our own enemies as well as friends. If I nurture or if I allow negative thoughts or doubts inside, I can do nothing. At the same time, if I only say here, others will do in that particular case, I did not know anything, but only I was able to do. Here I did not know anything, I was able to do. So I always look back at those success stories, and that charmed me up to take up the next challenge. And this also is true for our consultancy project, because when somebody comes to you for something, you may not know anything, but you have the basic knowledge. You are an engineer, you have acoustics knowledge, or mathematics, or fluid mechanics, etc. And then it's all question of sitting down, doing a deep thinking, and then learn from what is already available, and you will be able to extend it to solve the problem. So my idea of this project is not to tell you that born with that knowledge. I acquired that knowledge as I went along. And if I could do it, why can't I do it? So this is all I want to share with you, that things didn't happen as an accident. Behind that was basic faith or belief in myself or my capabilities. And that's, of course, God always was there.
Did acoustics choose you or you chose acoustics?
I told you the very first day that in my MTech project, I was asked to work on models. But I had studied 23 subjects during my MTech, and not a single one was on acoustics. So I knew nothing about acoustics. Okay? But just the confidence. If somebody has to do, why can't it be done? In fact, you won't believe. I went to the library, I didn't know where to start. I didn't even know, what could be the starting point. So all I did was, because I didn't know which even journals I should start with, I just started engineering. There used to be a big journal, a big one, that was just for engineering. And then I went to the index and looked for catchwords like muffler, silencer. And that is how I got a few papers. And then again, the question was, I went to their list of references, and I found one book was being cited again and again. And that was Fundamentals of Acoustics by Kinsler and Frey. Fortunately, I went to the book section, I found the book was there. And that was my start. And the rest is history. So what I'm trying to say is that first thing is you have to believe in yourself. And you say, oh my God, I don't know. When you say, I don't know, somebody should be telling you, and who is that somebody? Why can't that somebody be yourself? And you are actually fortunate. At least now all you have to do is go to the internet or Google and put acoustics, mufflers, silencer, and you will have hundreds of references. I had nothing. So this is how I got the first book. And then, I went through that book, solved everything, and then I also found that practically nothing had been done on silencers. So again, instead of saying, oh my God, then where do I start? Nothing, I got nothing. No, I looked at this opportunity. Here is something, nothing has been done. I can make the difference. And I did it. So I just responded to nature as it unfolded itself. And it worked.
Sir, can you suggest a book not related to science, you have been speaking about psychology, basically. And every time you come up with some sort of thoughts like that, you just suppress and go back to science. So I just wanted to suggest a related to psychology.
You know, things, you have that email ID. This is right thing. Because I have to. This is Munjal at IASC.ac.in.
Good afternoon, sir. What is the key difference between an ordinary project and an industry consultancy project?
Say it again.
So, what is the key difference between an ordinary project and an industry consultancy project?
See, there are two or three types of projects. One is called sponsored research project. Which really means that you identify a problem or which solution is needed. You have certain ideas. So then what you do is you write a proposal to funding agency like DSP, SCR, etc. Okay, and they have their mechanism. They have what they call program evaluation committee that's investigating review. And of course, they might ask you some questions and to answer in the interview also. So finally, you get the money. So that is, and that is now open-ended project. In the sense, you are getting that money to do research on it. At the end of it, what comes out is you are not responsible for it. Because the research project is something you also don't know what will happen. And they also know. So they don't accuse you at the end that you do nothing. All they expect is that something should come up. And that they make sure by interviewing you to see whether you are sufficiently confident about your own ideas. Okay. So in fact, I was chairman of the program advisory committee, DSP, robotics for MPH. So we used to hold hands and help the prospective investigators how we should proceed, how we should remodel the model proposal. And not only that, we used to even advise them to meet certain senior professors who have been successful in the field. All that we used to do. So it's not that it's not just a binary system that take it or leave it. So we used to help that people improve and then finally give them the process. So all that system is there. That's not sponsored research project. Consultancy project, no, it's not a research project. There because the person is interested, he really wants something concrete to come out. Okay? So for that, you have to know in advance that you know exactly what you will do. And then only you can take up the problem. Or it can also happen that those people have already heard about it and they are ready to take the risk and still give the problem. In fact, many people have given me that confidence, saying, "Oh, it's like you take it, whatever comes out, you'll see." Everybody may not be that fortunate, but at some stage you have a reputation, and then it just works. Like for example, I was telling you, as I was in Canada, these people from health industries, they contacted me. They wanted me to work on active master. So I told them that all my life I worked in a passive master. Okay. Then what they said, that we know that you will get through. Now, I was fortunate to have those kind of foreigners who had gone through my work and they knew that this man can do it. They had more faith in me than I had. But I played along. That's important. I played along. I said, fine. And it worked so well that in the 8 months of time, we could publish 6 international papers, apart from developing the whole active system, or HVAC system. So, you have to have that faith in you, and then nature takes care of it.
Thank you, sir.
Any other questions? Thank you, sir, for sharing your knowledge. We'll meet up tomorrow, sir.